Okay, extending Spring Data. So what I'm going to talk about today is Spring Data, and as you know, it has like a lot of components, different projects around it. I'm mostly going to cover Spring Data JPA and Spring Data REST, and also speak a little bit about Elasticsearch and Solar at the end. So yeah, here's a brief agenda of what we're going to talk. Everything that I cover here will be Ghostling Service Release 4. I know Spring Data Hopper came out a couple of weeks ago, but we had slight problems updating, mostly because of the querydsl and because of the Elasticsearch. So I couldn't make it on time to include the Hopper release here. So we're going to be covering Ghostling. Yeah, I'm going to start with JPA, with REST, a little bit of Solar, Elasticsearch, and then Q&A session. Right, so who am I? My name is Petar Tahchiev. I'm a Bulgarian. I started a company called Nemesis Software a couple of years ago. What our company is doing is actually building an e-commerce platform. And we're stepping on a lot of Spring, like a lot of Spring Data, a lot of Spring Boot, all sorts of Spring projects. And at some points it came short, so we had to extend it and we had to modify it. And this is actually what I have included here. I'm also an Apache Maven developer, and I wrote a book a couple of years ago. Right, so first things first, before I start, I'm going to need a project, and I'm going to have to generate one. Let's see. So we have come up with this website that you can put your project details, and then on this side here, it's going to generate you a project. What I'm going to use is version 1.0 snapshot. You copy the command. You go to your, let me see. Yeah, I have one. So you go and paste it. And what this is going to do is actually it's going to, it's like a Maven archetype that will generate a project for you in this folder here. It's called demo. And it will allow me to play with the project and show you, real-time demos. Okay, yeah. So now this is generated. I will actually very quickly build it, and I will continue with my presentation. In the meantime, it's being built. So I'm going to tell you a little bit about my requirements. When we started building the e-commerce platform, we wanted to make it modular, right? So the customer would have the ability to select different modules. And like you can see here on this picture, they have like a finite number of variations, but in the end they have some sort of combination of modules that they can pick. And we wanted to have the different tables in the database and with different columns and etc. So not to clutter it with something, some extra tables or properties or columns that they don't use. So like in this case, if they select the CMS and the core, which is the red box, what will be generated is the red site entity, which only has name and a theme, because these two properties come from those two modules. But in the end, if they go for the blue modules, like a core and a commerce, and they put them on the class path, what they will have is a name and a default currency. So this was the primary requirement that we wanted to have. And the way to do it actually is, we thought really about quite a lot how to do it. And we came up with the idea of really not using JPA entity classes, but instead using JPA entity interfaces. And have those interfaces in the modules. And then as soon as the customer selects the modules that they want to use, we do a class path scanning, we find the interfaces, and we generate the classes, the JPA entity classes on the client side. Right, so this has been finished now. So I can go to the storefront and start the website. Run profiles. And in the meantime, I can quickly show you what it looks like, because this was built now. And okay, so in the core, we have target, generated source annotations, nemesis platform, core entity, like for instance, CMS, And you can see what this looks like. It's a generated class, but this is on the client side because I have put these in these modules. I have these in these fields here generated. Okay. So what does that give us? This gives us that the idea that we have to use in our modules. We have services, repositories, and entity interfaces. And the entity classes are generated on the client side. So we don't have access to the entity classes. So how do we make Spring Data repositories to work with our entity interfaces? Well, one way is to actually generate the interfaces as well on the client side. But then our services will be working with the repositories, so this means that we don't have access to the repositories anymore. So we have to generate the services also, so it gets really complicated. And what we decided to go with is actually extend Spring Data so that it can work with the definition interfaces instead of the actual classes. Because, like I showed you, we don't have access to these classes. They're generated on the client side. So if I open one of, like, for instance, let's see, product repository. Now, this is a Spring Data repository, and it works with these so-called interface definitions, like product entity definition. And this is purely an interface with getters and setters and some JPA annotations. And how do we actually tell Spring Data to use these interfaces? Because, of course, it's going to complain, like it was built to be used with classes. OK, well, the way we do it is we actually went to platform core auto configuration. So you know this annotation probably, if you have used Spring Data with JPA. You know, this enable JPA repositories, and you provide the repository path that it's going to scan. But it also has like a nice addition to it, repository bean factory. So what we have done is we went and created our own repository bean factory, which will, of course, do nothing else but instantiate a JPA repository factory. And it will allow us to override this method called get repository metadata. And it's going to allow us to return our custom metadata. Now, the metadata in Spring Data is an interface. The repository metadata is an interface which actually tells you all the information about a repository. If you have a repository interface, it's going to tell you, you know, what is the domain class, what are the CRUD methods about it, is it a paging repository? So everything you need to know about a repository is going to be contained here. So we create our custom repository metadata, and like from Gosling Service Release 1, they included this nice method here, get alternative domain types. So what does this do is it will allow you to specify not just the class that the repository sees, but also like a bunch of alternative domain types that you want this repository to work with. And of course, all we had to do is literally extend, and when creating the custom repository metadata, like just provide alternative domain types, and we have here the domain interface we are storing during the bootstrap of the application, and it works. Spring Data starts accepting these domain interfaces as first-class citizen, and it starts talking to them, and Spring Data JPA works fine. Unfortunately, that's not the end of it, because if you start working with REST, well, the JPA is fine, but then you start, then you want to expose your repositories over REST. And then you start hitting problems. Let's see how this goes. OK, so the application server has started. Let me very quickly verify that. Oh, yes, sorry. Storefront, and then you rest. Yeah. OK, cool. OK, one other addition that we added to the Spring Data JPA was the auditing. like our domain interfaces, they all extend, like if you have a look at product entity definition, this is the domain interface. Well, it's going to extend abstract entity definition, and inside the abstract entity definition, like the Spring data, we have here these nice cool annotations like last modified by and created date, because all of our entities are actually auditable, and we have of course specified the entity listener, auditing entity listener, so that every time we persist something in a database, these fields like last created by and last created date will be stored. Our repositories, like if you have a look at the product repository, of course, again, it extends the base entity repository, because it's catalogable, extends also catalogable, but it extends a base entity repository, and we made our base entity repository to extend auditable entity repository, which provides you some really nice methods like find by last modified date and etc. This has been proposed to be included in the Spring data, so I'm not going to talk about it more, because I think they're going to include it. It provides you with a base repository that you can use those 4 methods. Okay, moving forward. Now, the real problems like started when we wanted to expose the repositories over the REST. And like you've probably been to the talk this morning of Oliver Gilke, where he mentioned that REST is not CRUD, HTTP CRUD. Well, of course it is. It's not. Actually, this is quite true, but REST is a lot more than HTTP CRUD. And right, so our requirements were also to build a backend system for administrative purposes of our web store. So we wanted to make it a CRUD backend system, like a basic CRUD. So of course we wanted, because REST is more than CRUD, we could use the Spring Data REST. So this is exactly what we did. We exposed all the repositories via REST, and let me show you a little bit of flavor of how it works. Yeah, this is the backend. Where is it? Okay. So this is our backend. So when you see it, you get presented with this login screen, and the way it actually works is when you log in, we take the username and the password from the field, and we send them to the website, and then the website will actually validate them, and it's going to return here the nemesis token that you can actually subsequently call again using this token, and we're going to see who you are, what kind of user groups you are in, etc. That's all cool, but how can we hook this into how could we hook this into the Spring Data repositories? Let's see, REST services core config. Okay, so we want, when the user accesses these repositories from the website, we want to have the option to actually check if he's passing the header, the xNemesis token header, or we actually want to detect his cookie. So what we're doing here is we basically declare 2 session strategies. The one is with the header, where we check the header, and the other one is with the cookie. So if the one falls back, if the one doesn't succeed, it will fall back to the other one. And a little bit more on the authentication. We have here the security config. It's pure Spring security, where we say the path matcher this is a property from Spring Boot, and we disable the headers for CSRF is also disabled. And we add a filter, which is our custom filter. It's called REST authentication filter, and we're going to say, okay, you're going to listen on REST login and take the username, the password from the requests. They're passed as headers. Try to create the username password authentication token. Set the details and call the authentication manager with this. And then finally, if there was no exception, set the authentication in the security context holder. And finally return the header name, which is xnemesis token, return the session ID as the token. So, okay, moving forward. Navigation menu. So when you log in, let's see. When you log in, you get presented with this screen. So on the left side, you see the navigation menu, where the folders in the menu are actually the modules that you have added in the class path. And each module will bring you extra JPA entities. So if you open one, you're going to see all the JPA entities that come from this module, like the comma, strings, product, and etc. We wanted to use the top-level resource, like if you go to here, /rest, and we wanted to see which kind of repositories you have to build this navigation menu, but unfortunately we couldn't. So we had to come up with a custom controller. And we couldn't because this actually returns all of the different kinds of repositories that you have. And what we have here is not all of them, but first they're grouped. And second, if I log in with a CMS manager, you will just see the ones that you have permission to see. Okay, so what we have proposed, at the moment it's a custom controller, but in the future, because there's this data rest 823, we have proposed to actually include a top-level projection where you can specify, I want to see only the projection equals commas, and then it's going to show you only the commas repository. So you can say projection equals CMS, and you can only see the CMS repositories. Yeah, like I'm gonna mention here quite a few bugs. So if you find something useful, just go for it and vote and comment, and I don't know, just put some pressure. Okay, moving forward, CORS. What is CORS? I think it stands for cross-origin resource sharing, I think. Well, it's needed when you have JavaScript, because you're accessing resources from another domain, and usually the browser will block it. And at this point, we have a backend, which is pure JavaScript, and it talks with the server via REST. So that's why we need it. We came up with the idea of writing our own CORS filter initially, because Spring didn't have one. But later, in the latest version of Spring Boot, they included one. So we had to ditch our custom CORS filter and use theirs. It has a lot nicer support with the Spring Boot properties, and you can configure it quite easily. Okay, so it's not this one. It's not here. All right, so it's pretty much a filter registration bean where we call the CORS filter from Spring Framework 4.2.6. Like I told you, it's been included in the last releases, and yeah, you can configure it with the Spring Boot properties. And just by adding it here, what it's going to give you a CORS. So like, not quite sure like how many of you are familiar with CORS, but it's actually like providing you with the ability to send first an options request, and then the server will respond to this options request, telling you which methods you're allowed to perform on this URL, which kind of headers you're supposed to you're allowed to provide, etc. So very quickly, if I go here under the network tab and click this one, like there it is. Okay, this resolution is killing me, but I just have to deal with it. What? Okay. There it is. First, you initiate an options request, and then the server will reply with, yeah, allow credentials are true, and these headers, X nemesis token is allowed, and the methods that are allowed are get, put, and post, and etc. And then you actually make the real one get, and then you can provide the X nemesis token for the authentication and all the others. Okay, moving forward, the next requirement was, when a customer selects a product or some entity, they would get presented with this search form. Okay, it's a lot better when you view it on a nice resolution. I should hide the tree. That's a good idea. Let's see. What happened? Okay. So you get presented with a screen that has search on the top and results on the bottom. And the search actually consists of every attribute that the entity has with some predicate, like is starting with, and then you can specify some value, or is ending with, and etc. Our first implementation, our initial implementation here was actually to use the methods under the repository /search. So if you go under here and say product, and then you type under search, you see all these find by whatever methods. So this was our first implementation. We take all the methods, we parse them by the find by name, find by prefix, and then we put here all the other all the options that are available for this field. Like this has one major drawback: you cannot combine two attributes. So if I want to search for an ID that starts with let's say Africa, and for instance let's say a catalog version that is equal to say online. Yeah, this one. Now, what's going to happen is I want to see all the ones that are starting with Africa, their ID, and they have this catalog version, solar codes online. So with the previous implementation, this wasn't really possible because you have one single method, find by UID starting with, or whatever. So we had to come up with something else. And just to give you a very quick overview of what's happening, when I click on the search, this is the request that gets sent. REST, product, size, and then there's this filter. I'm not quite sure if you can see it. Okay, there's this filter, starts with UID Africa, and then there's this EQ. Okay, equals true, and catalog version is this, and the projection is search. This is actually OData. OData stands for, let's keep moving. OData is an OASIS standard. It allows you to query in a very complicated, if you have a REST service, it allows you to query in a very complicated way this REST service and provide very complex parameters and very complex expressions, like I want this and this or this and bigger than this and etc. It's a pretty nice project. I think it was started by Microsoft. Not quite sure though. Right. So this query here is OData, but how do we hook it now to the Spring Data repository? Well, it turns out that the Spring Data JPA supports something called querydsl. So if you were to the previous session of Oliver Gieke, he was explaining the querydsl in details. But really what it is, actually it allows you to define some sort of predicates. So if I go now to product repository again, and it extends from base catalog repository, and it extends from base entity repository, and it has here this querydsl predicate executor. So the repository can extend from querydsl predicate executor, and then immediately it starts working with querydsl predicates. Now the querydsl predicates are very quickly. I can show you some. Okay, some example. I think. Yeah, you can define things like person.lastname ascending, order by, and no, where the person children's size is equal to select. So you have, again, the very same idea, but just implemented on a JPA level. So we need somehow to get this URL and translate it into the querydsl, into a querydsl predicate, and then just pass it to the repository and everything's going to work. And this is pretty much exactly what we're doing. So, okay. We go back to the REST services core, and we have here defined a bin of type root resource information handler method argument resolver, which comes from, yeah, no, it's quite long. Yeah, no, this one is even longer. So this one comes from Spring Data, and this is actually the bin that we want to replace with our implementation. So, now, first things first, we have to check if the querydsl is present, and if it's present, we can create a predicate builder. Now, this predicate builder actually does nothing more than just delegating down to a predicate parser, yeah, to a querydsl predicate parser. So this querydsl predicate parser is going to take the OData expression, and it's going to, first it's going to match all the entity path, if it's a string, if it's a Boolean, if it's a number. So there's like a lot of magic here, or a lot of implementation details that I'd like to spare with you, but pretty much it's 700 lines of code. This is what it's doing. It's taking the OData expression, translating it into a querydsl predicate, and then we can pass this to a repository, and immediately we get the result back. Right. Now, this would have been all fine if we were allowed to substitute this, but like a problem occurred. This Spring Data comes with querydsl where blah 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 argument resolver, which unfortunately, like if you have a look at it here, the one that comes from Spring Data is package private, so you're just not allowed to extend it and inject your own predicate builder. So what we had to do is we actually had to come up with our own. So our own is basically a copy paste from the one from Spring, purely because theirs is package private and we're not allowed to inject our own. Okay, moving forward. Right. Sorry? Yes, I don't think there's an issue for this. Is there an issue for this? Yeah, just vote for it. If you find it, vote for it. It's good to make it protected at least, so we can extend it and inject our own predicate builder. Cool. Yeah, I told you about, so we have defined our custom querydsl predicate builder and a custom predicate parser, so that we can parse the OData into querydsl. Projections. Right, so Oliver Gicker, again, in the session before me, explained very briefly what projections are. And for those of you who don't know, I'm going to spend a few minutes. Projections are basically, in Spring Data, they allow you to, the JSON that is returned to be actually shrinked and not just limited in terms of size and just omit some of the attributes, but also transformed. Like very quickly, again back to the rest. If I have here, what is it? Product. Okay, so product returns a pretty big JSON, like you can see here, but like most of the time, I don't need the whole JSON. It's just a pure waste of bandwidth. So what I can do here is if I can specify projection equals search, and again, it's just shrinking it. It just emits most of the stuff that I don't need. This is all cool. Unfortunately, again, we hit a problem because the way projections are defined is you have to specify an interface, and you know, all the attributes that you want exported, you have to say, you have to create getters for them. So imagine you have a product entity So if you want to create a search projection, you have to create a product projection interface and say get name, get price, and all the gets that you want to be returned. You have to create a getter method there. But like I told you, I don't have access to the JPA entities because those are generated on the client side. So we had to come up with something else. And because we want search projections all the time for all of our entities, purely because when I click search here, I need a search projection. I don't need the whole JSON that is returned. Like first solution was pretty much to generate projections on the fly. And you can do that by going to the, let's see, it's not here, it's in the nemesis repository REST configurer. Right, so there's this method called configure repository REST configuration, which you come if you extend repository REST configuration adapter. And then you somehow find all the entities. Like in my case, these are interfaces that I have access to, so I can find it. I say if it's an interface, just this demi lambda here, and then create interface maker is actually a class in cglib. So what this is going to do is going to create a class during runtime and put it in the memory for you, and I can say copy all the methods that have this annotation result property on your interface. And then, config get projection configuration, I can say add this projection, with name search and use this interface. Now, this works pretty much out of the box, like just a couple of lines. It's great, it's awesome. However, cglib is a really old library, so it doesn't support annotations. And Spring data projections allow you to specify the add value annotation where you can modify the result that is returned. So if you don't like some property, you can call a service in this add value, or you can modify it by concatenation or whatever. And I really needed this attribute. So our second approach, this was the first one. It was okay, it worked. We used ByteBuddy because ByteBuddy is a newer library and it supports annotations. You can create classes in the memory with annotations on them. However, ByteBuddy is not part of Spring Core. So when I started integrating it, I lost a couple of hours with some random exceptions. I couldn't figure out what's happening. And then we went for a third approach, which is generate projections on the client side. Now remember, I have interfaces in the modules that the customer is going to put in their class path. And then I'm going to generate classes on the client side. Then I can, of course, generate projections as well. So this is exactly what we're doing, as I can show you one. Yeah, site entity is here, and we have generated site entity projection here. So if I open it, now this is again a generated class, and it has the projection annotation, and it has all the getters that I need. And this generation again happens with the same library J-code model with the one that generates the JPA entities. Okay, moving forward. Now, JSON schema. Well, I'm just going forward with this backend console here. Now, the search is fine, but our next requirement was when a user right-clicks, we have an edit here, or we can double-click it, and then this pop-up comes where the user can edit their, in this case, product. So, first of all, we have to know, here's a requirement. If you open this pop-up, you have to know several things. Like this unit here, what is it? Is it integer? You need to know the type of the field. You need to know if it's an enumeration. You have to know, the values of the enumeration. You have to know if it's a read-only, if it's not. You have to know if it's a required or if it's not. You have to, and last but not least, you have to know on which tab to put it on, because I have here like a lot of tabs. So we solve this, like most of this information you can get from JSON Schema. Let me just quickly, so here's Postman, and I can go to storefront REST profile product, and for this I get a nice JSON schema. For those of you who are not familiar, it's a Oasis standard for defining the way the JSON response should look like. But this is pretty much okay for me because this is exactly what I want. Like for catalog version, it's going to return me that the title of the field is catalog version. It's read-only false, and the type is string, but the format is URI. So now I immediately know that it's actually a relation to another entity. And I have given you here an example of content unit, which also gives me a title and a description. So I can specify a description by going to, let's see. If I go to the core, src main resources, I have provided here REST messages property files where I have given, where I have given REST description is always has to be there. Then you specify the entity that you want to specify a description of, and then the attribute of this. And then you're giving this description. And what's even more nice is that you can have it localized. Like this one is in Bulgarian as well. So you can also specify a title for it and a description. So now, if I go back to Postman, it's this one. No, sorry, it's this one. I have the option to specify here headers. Do you guys know where the headers are? No? Oh, shit. Sorry?
Go up because this is the response.
Yeah.
Key value.
Oh, yes. I can specify the accept language is Bulgarian, and I will probably get it in Bulgarian. And this all comes from the REST messages file, and then I can use it here to provide a tooltip. What's this field is about, the title also for the field, and etc. Everything that I need actually comes from the JSON schema, except for which under which tab to put this attribute. And for this, I actually created another controller to expose some more information, which tab needs to be. Of course, you can do it on the client side, but the way we decided to go for is provide some server-side information. This attribute goes under this tab, for instance. Okay, moving forward. This is the things that JSON schema exports. It's going to tell you name, description. It's going to tell you the type of the thing, if it's a read-only, if it's a required. Right. One other thing, though. What happens if you... No, actually, I'm going to come back to this later. We wrote a bunch of custom resource processors. Now, a resource processor is actually the Spring Data way to actually modify the JSON that you want to have returned. Like, for instance, if you want to add a link to the response that is returned, you can actually do it with a custom resource processor. In this way, for instance, let's go to, again, our REST. We have medias. So every time you upload a picture, we store it in our database, a media object. And this preview URL is actually constructed on the fly. So it's not in our database. It's something that comes from, with the JSON, but is not stored in the database. We only store the URL of the media. And the way we have it in the JSON is that we have media URL, media resource processor. So we get the media entity definition is the JPA interface, and we say if it's external, just copy the URL. If not, then resolve the URL with this, and this will actually add the, this will actually set the preview URL in the response. And then finally, here's a bunch of different resource processes that you can use. If you want to put a link under /rest, you can use repository links resource. Like, I don't think we have done any, but it's always easier to check. Profile, yeah, we have done a few. All results markup is actually some of our URLs that we use to define which property goes under which. Like I told you, I have created a custom controller that tells me which property goes under which tab. So all results markup and results markup are these custom controllers. And I've put them here as links so that if you're drilling down through the links of this resource with a REST shell or whatever, you have the link here and you can follow it. Moving forward. So if you want to put it there, you use repository links resource. If you want to put it under search, you use repository searches resource. And if you want to put it under a certain entity, you go with persistent entity repository. Now this is going to put it under every entity. Persistent entity repository resource is going to put it under every entity. But if you want to put it just under the product, you have to use a resource and then this generic. But what about REST product? Like if I want to put it under REST product, there is no way. There is a data REST 817, which I opened. If you want to add a link to the product entity type, there is no way at the moment. So yeah, if you guys think it's worth it, just go and vote for it. Validation. Now the next, moving forward, my CRUD application is fine, but it needs validation. Like for instance, I'm going to close this and I'm going to need this again. Like for instance, if I want to create a new product, create new product. Now it opens like a blank one, and if I click save, it's going to say, yeah, you don't read it, but it says the catalog version cannot be empty. And this is purely because I have here under this tab, this catalog version, you see, and it cannot be empty. So validation is performed if this validation is performed with JSR 303. So if I open product entity definition, it extends from abstract catalogable entity definition, and here we have not null. So you see, this is Hibernate validator, stopping me from creating a stupid product without catalog version. The way to hook this is not out of the box with Spring Data, so they don't have any validation. You can provide custom validator, but you have to write it on yourself. The way to do this is actually you have to go to nemesis. Okay, so here it is. There's, again, the same repository REST configure adapter, and you have to override this method configure validation repository event listener. And you have to specify under which circumstance you want your validator to work. In this case, it's just before create or before save. Because I wanted to make the validation to work with the same REST messages property file, and not some else, because by default it's going to work with. Thank you. By default, it's going to work with the one that JSR 303 provides, and it's actually just creating several property files. I wanted to put all of my validation messages under here, like JAVX validation constraint not null. This is the translation. I wanted to put it everything in this file. So I had to create my own custom validator. Here's my validator factory bean, and I'm telling him use the default message properties and fall back to the REST message properties, and call this validator on before save and before create. Okay, and this is pretty much how it works. Everything now is in one single message source. If you want to localize the validation errors, yeah, you just have to specify them in the other bundle. Now, here's a bunch of limitations that I discovered, at this point. If no repository exists for a given entity, it actually blows with an exception. So if you have a product, and you have product repository, but then you extend the product with my product, and you don't have my product repository and try to access my product, it blows with an error. It would have been nice if it just fall back to the parent, but it's not. The projections for the top-level REST, like I told you, when you go to /REST and ask for a projection, this is a data REST 823. The way to enrich the JSON schema. The JSON schema provides everything except for the fact where this property, under which tab this property should go. So I wanted to inject this, but I couldn't. So there is no way to enrich the JSON schema at this point. Spring Data Solar doesn't support highlights and facets in the same query. So if you have a Solar and you want your highlighted result with facets, it doesn't support that. Yeah, just a shame. And Elasticsearch does not provide aggregated page in the latest Hopper release. I have opened the ticket, but it's not here. So, okay. What else? I think that's it. I have a few slides about Solar and Elasticsearch, but I don't think I have time. The way we do it with Solar and Elasticsearch is we have a POJO with the add field annotation on it. And with Solar, it works fine. The field annotation can be used on both the attribute and the method. But with Elasticsearch, it doesn't, because the field annotation only can work on attribute and not on methods. So if I provide, in one of the modules, if I provide a product POJO and the customer wants to extend it and he wants to override the setter, he can't. And that's data ES20. Yeah, and thank you for your time. These are some information about me and how to stay in touch, my Twitter, and etc. So if you have any questions, I'm here to answer. If not, they're giving me a sign that it's over. Yeah, go for it.
Great presentation, thank you. You were mentioning data.
Yeah.
So you mentioned data at one point. And we were also experimenting with it, and we found the Olingo library. Did you consider using that?
Yeah, I think he's the right to answer. Olingo library, yeah, we are using the Olingo. It's the implementation of the. Yeah, this is the implementation we're using, Olingo. But the OData is the spec. Then
why did you implement the query?
You're using Olingo to parse the query and translate it to querydsl.
Yeah.
Because that's what comes with Spring Data.
Because the querydsl expects a predicate, and we need something to pass the OData request.
Yeah, we chose it because it's quite powerful query.
Which version, 2 or 4?
4. Anything else? Okay.